Describe briefly the functions of the three segments of NPN transistor. The three segments of the NPN transistors we can define like this. First one is emitter. It supplies the large number of majority carriers for current flow through the transistor. Second one is here, it is the base. It allows most of the majority charge carriers to go over the collector. Alternatively, we can say it is the very thin, lightly doped central segment of the transistor. And the third one, it is collector. Collects a major portion of the majority charge carries supplied by the emitter. This is the some of the functions of the three segments of the NPN transistor. Second part, draw the circuit arrangement for studying the output characteristics of NPN transistor in CE configuration. Explain how the output characteristic is obtained. So we'll see the diagram here first. Output characteristics of NPN transistor in CE configuration. So here, if we get the output here, so first here it is a IB current is there and VB current is there here. We need to study this condition by keeping a VCE, it is kept constant. Then for the input, we need to study here by analyzing the IB current and voltage of input by kept VCE at constant value. Then if we want to study the output characteristics here, then we need to study analyzing the IC and VCE by keeping VPE, that is a IB at constant value, by analyzing the VP here. Then if you are going to change the VCE value, automatically the IC will also changes here. The graph we can see here looks like this. Collector current IC in microamperes, collector to emitter voltage VCE in volts. So okay, if you are going to change the VCE value, then the IC value is also changes here. Third part, draw the circuit diagram of a full wave rectifier and explain its working. Also give the input and output waveforms. We'll see the circuit diagram of a full wave rectifier is shown below. First, the primary coil of the secondary transformer. This is the primary coil of the secondary transformer. And this is the secondary coil of the secondary transformer. The one end of the secondary coil of the secondary transformer is connected to the diode, that is PN junction diode. And it is connected in between the load resistance. And the another end of the secondary coil is connected to the another diode, that is PN junction diode. The first one we called as this is the D1 and second this is the D2. Okay. When we need to know here what is the rectifier. The rectifier is a device which is used to convert the AC input signal into the DC output signal. Okay. Alternate current of the input signal is converted into the direct current of the output signals. We are going to use the rectifier here. How it works we will see here. When the input signals, that means the alternating current of the input signals, it is like this. The alternative waves it will be forms like this. Then when the positive wave and the negative waves is there here, and in this case we can say this is the A, B, C, D here. And when the alternative means in this case in secondary coil this will becomes this is the A value, in this is the positive value is there, and in the B value this negative value is there. Due to the mutual induction, then in the secondary coil this will also become the positive and this will becomes the negative. Then the current will be, wave will be generated and the current will be produced from the diode 1 in the forward bias. Now the diode 1 is in the forward bias and the diode 2 will be in the reverse bias. Then the it produces the signal in this format. And when the negative alternating current in the negative loop is there, then the A point will become negative and D point will become positive due to the mutual induction. Then the C will become negative and D will become positive. Then in this case, the diode 2 will produce the signals. In this case, the diode 2 will become the forward bias and the diode 1 will become the reverse bias. Then also the signals will be generated in the same format like this. Okay. Then we'll see the brief explanation part of this one like this. Because of the center tap in the secondary of the transformer, diode 1 and 2 get a forward bias in successive half of the input AC cycle. However, the current through the load flows in the same direction in both the half of input to AC cycle. We therefore get a unidirectional rectified current through the load for the full cycle of the input's alternating current. Then we'll see the input and output graph here. I told this is the input graph of the AC current, plus, minus, minus, and a plus and minus value here is the minus value. Okay. Then the output wave from the DC, it will be looks like this. This is from the diode 1 and this is from the diode 2. Okay. So this will be 30 minutes.